The following animation is an exaggerated comparison between copper and optical fibers. A stickman is using a copper wire to play music. A week later, sound is heard at the speakers. Stickman is obviously very angry and rips apart his new Apple computer. On day 2, Stickman opts for a brand new fiber optic cable, which is much faster than copper wires over a large volume of data. Optical fiber technology takes advantage of the fastest thing in the universe, light, whereas copper cables use electrons to transmit data that travels at only 1% of the speed of light. For example, an optical fiber system can manage 10 times the number of phone calls at once than its copper counterpart. This is the reason optical fiber dominates the forms of data transmission, delivering 99% of all data. However, internet data traffic is doubling every 16 months, and some users require massive amounts of data, therefore capacity needs to be improved. Optical fibers have lower attenuation, but what is attenuation? Throughout a fiber cable, attenuation or power loss occurs. Amplifiers are used to regenerate the signal. If the original signal attenuates by 3 decibels, the ratio of Pout to Pin is halved. Shown here is the Stick World data center, which stores data on the cloud for millions of stickmen. The use of data centers have become vital to governments, businesses, and certain individuals. Data centers store computers which are used for specific functions, such as managing networks, backing up data from individual computers to one place, and managing applications like email databases and internet presence. Data centers have also become increasingly used for cloud storage solutions, meaning data centers have to receive and send very rapidly massive amounts of data, meaning capacity is a major concern for them. And with new forms of communication being introduced that need data centers such as immersive videos, augmented reality, and virtual reality, the need for data transmission is increasing at an alarming rate. Too much power transmitted would cause the cable to melt. Low cost and high speed upgrades for data connections are needed. Ways in which light signals are transmitted in optical fibers are called modes. In other words, a mode is simply the route which the light beam travels down the optical fiber. There are 2 modes, the single-mode fiber and the multi-mode fiber. Single-mode fibers have a small core diameter, which only allows light to travel in one direction without bouncing off the edges of the cable. Hence, signals can be transmitted with a higher precision over a longer distance. Multi-mode fibers have a large core diameter, thus it allows rays of light to disperse as they enter at different angles. Precision can only be maintained for a short distance for this mode.
There are 2 types of spatial multiplexing, single mode and multi-mode. For single mode transmission, we have multi-core, which refers to several cores embedded in a fiber cladding. In terms of multi-mode, this is a large single core that allows light rays to enter and disperse at different angles. Problems of multi-core and multi-mode. There are 2 main problems with using multi-core optical fiber. Firstly, crosstalk between cores in multi-core fiber can interfere and corrupt the signal. Secondly, multi-core fiber only allows communication with more expensive equipment. For multi-mode, there is only one main concern with using multi-mode optical fiber. Multi-mode fiber can only support short-distance transmission. Data center solution. Multi-mode fiber will be more suited for data centers, as individual data centers are not normally involved in long-distance transmission. Secondly, multi-mode fiber allows communication with low-cost equipment to be possible.
So, what is our solutions for the future?
Hollow optic fibers are 30% faster than current cables, meaning they travel at roughly 99.7% of the speed of light. On the other hand, a potential problem with this new technology is that all existing fiber optical cables would have to be replaced.